Hello, my name is Heiko Paulheim from the University of Mannheim, and I present joint work with Michael Voigt, who was a master's student of mine. And together we worked on the topic of bias in knowledge graphs, and we conducted this empirical study with movie recommendation and different language editions of DBpedia. So let's see what this is about. Movie recommendation with knowledge graphs is around already for a couple of years. And in the first wave of those knowledge graph-backed movie recommenders, what people did is they looked at different features of those movies. So like what's the director, what's the actors, what's the genre of that movie, and so on. And then based on those features, they built content-based recommenders and say, well, if a person liked movies by one director, we recommend further movies by the same director or movies with the same people acting in those movies, and so on. So this was the first wave, so to say, of these knowledge graph-based recommenders. And more recently, we see a lot of stuff using knowledge graph embeddings. So what knowledge graph embeddings do is they project each entity in that knowledge graph into some vector space. And then the assumption is that entities which are similar are close by in the vector space. So when we look at movies in our example, and you look at this right-hand side distribution here, you see there is each movie is now represented as a point in that vector space. And you see some clusters here. So on the top left, you see this green cluster of Disney movies. On the top right, you see that red cluster of Star Trek movies. Down here, you see a cluster of Batman and Superman movies. And then the idea is, well, if this similarity reflects the similarity of the items, then we can exploit that for recommendation. So if somebody just watched Bambi, for example, we can then recommend movies which are close by in the vector space, like Cinderella or Dumbo, for example. And as I said, these techniques have been very popular in the recent years, and we've seen a lot of works using RDF2Vec and all flavors of Trans-E, Trans-D, Trans-R, and complex and Node2Vec, and so on and so forth. So people use all sorts of embedding techniques to build those recommenders. And when you read the corresponding papers, you very often find sentences in the evaluation section which read like, in our experiments, we varied the parameters epsilon and gamma, or we analyzed the performance using trans X and trans Y, and usually our own embedding approach. Or we compare different embedding modalities, like we compare word embeddings, knowledge graph embeddings, and joint embeddings, or we consider different pre-processing techniques, and so on. So people build some methods, and then these methods have all sorts of knobs you can turn, and people turn them in all sorts of directions and then report the results. A sentence you almost never read in those papers, though, is the sentence saying, in our experiments, we compare the performance of using knowledge graph X and knowledge graph Y. So, for example, we run the same method, but for once we use DBpedia, and the other experiment we use Wikidata, and then see how the results differ. So what most people do in those papers is they pick a knowledge graph up front. So like DBpedia, most people use the English version of DBpedia or Wikidata, and then they fix that, and then they vary all sorts of aspects on their parameters. So we were asking ourselves, don't we lose something here? So isn't there some influence that the choice of a particular knowledge graph have on the downstream system? And we also want to look not only at the quantitative differences. So how does the F1 score change when you use Wikidata instead of DBpedia? Does it go up or down? But we also were interested in the qualitative differences. So we assume that knowledge graphs differ in bias, in coverage, in level of detail, and so on. So maybe this also reflects in the downstream applications. So maybe a movie recommender trained with a different knowledge graph has a different bias. So in other words, what we do in this study is, unlike all these papers which say we fix the knowledge graph and then we change all the parameters up and down in our methods, we fix the method once and for all, and then we just change the knowledge graph and see what happens. So as a basic data set for our evaluation study, we used MovieLens 1M, which is a standard movie recommendation benchmark data set, which consists of a couple of thousand movies and users, and altogether of 1 million user ratings for movies. And couple of years ago, this was pre-processed by people at the University of Bari who already provided a mapping to DBpedia. And we used this processed data set by the University of Bari and further post-processed this by, for example, looking at links which are outdated in the meantime since this mapping was done. And the resulting data set had a little bit more than 3K movies overall. On the knowledge graph side, as I said, we wanted to introduce some variants, and we decided to use different language editions of DBpedia. These different language editions, they are extracted from different Wikipedia languages. So there is Wikipedia in English, which gives you the English DBpedia. There's Wikipedia in German, which gives you the German DBpedia, and so on. And all of them are usually run by people who provide mappings for those particular languages. So there's also different user communities which create those DBpedias. And this selection was based on, for the one hand side, the size of these DBpedias overall and the coverage of this movie evaluation data set. So the assumption here is that these systems you build on these different DBpedias, they probably have some tendency. So for example, we assume that if you train a system using the German DBpedia, then this recommender should have a higher tendency of recommending German and Austrian movies just because they are better covered, they are described in more detail, and so on. And we might also expose some other coverage biases. So maybe there is some other bias in terms of genre. Maybe a recommender trained on one language DBpedia has a higher tendency to recommend movies from a particular genre. So this is also something we wanted to look into. So when we created those data sets, and we already had this movie lens data set, which was linked to DBpedia. And then we looked at other language editions, and they are all interlinked. So we can simply follow these old CMS links between the language editions. And then we picked a set of five language editions, as I said. So all of those which have a significant coverage, and we retained only the movies which are contained in all of these 5 language editions. The rationale here is that each movie recommender should, in theory, have the chance to recommend the same set of movies, and then we can look at the difference. So this is what we did, and we followed some general suggestions of the people who built this original DBpedia mapped movie lens variant. They suggested, for example, removing the top 1% rated movies. So these like overall globally interesting movies, or to remove users with less than 50 ratings, or to remove unrated movies. And we did all this pre-processing, and finally we were left with a data set of close to 2K movies, 675,000 ratings, and 3.6 thousand users. And this is the data set then we used the evaluation on, and we trained a recommender and looked at its behavior. For generating the recommendations, as I said, we fixed the algorithm up front. So in that case, we used RDF2Vec, and we simply used a parameter set which was reported in the past to work well for recommendation. So we used skip gram embeddings, we used a walk depth of 4, we used a 2-dimensional embedding vector, and then we compute the similarity of movies on these vectors by using the cosine similarity in the RDF2Vec space. So how do we get from movie similarity to recommendations? The first step we do is we compute a score for each user and movie. So for all of these movies that a user has not ranked before, we compute this as a weighted rating of all the similar movies. So we weight each movie by the cosine similarity to the movie at hand, multiply that with the rating, and normalize this by the overall sum of similarities, and then we get the user rating, the fictitious user rating for an unrated movie. And then for each user, we take a holdout set of movies that this user hasn't ranked and recommend movies from that holdout set. And we do that by using the top scoring movies according to this scoring we computed, and then recommend the top end movies to the user. And from there, we can then evaluate what the quality of the of the recommendation is, but we can also look into the recommendation per se to see what is actually recommended there. So first of all, the quality of recommendations is quite straightforward. We compute an F1 score. So for the sold out set, all the movies that the user rated positively were treated as recommendations which are valid. All the movies that the user ranked negatively were treated as recommendations which are invalid. And then we have positives and negatives and can compute an F1 score. As I said, we are more interested actually in these patterns in the recommendations. So we look at particular categorical features like the language of a movie or the genre of a movie. And then we look at what is the probability of this recommender recommending movies from this particular categorical feature. So across all these recommendations that this recommended us for all of the users, we look at these recommendations and compute the fraction of recommendations that have this particular feature. And of course, we also know the expected value. So if we know that, let's say, 5% of all of our movies are from a particular genre, we would say, well, the expected value of recommending movies from that genre is 5%. And then we can look at, is it higher or lower than its expected value? So here we have an example. We want to look at how likely is a recommender, a particular one, to recommend movies in German. So we look at all the recommendations which are in German divided by the overall number of recommendations that were given by that recommender, and then we know what is the overall probability of this recommender algorithm recommending German movies. So the first thing we looked into, as I said, this is not the main focus, but for the sake of simplicity, we also looked into that, is how good is a recommender trained on these particular knowledge graphs. And we can see there is most of them score relatively in the same region, like the one trained on German, French, English, and Italian. The Russian one, so the one trained on the Russian DBpedia, scores a lot lower than that. What we also see interestingly is that most people, as I said, if they use DBpedia, they use the English version of DBpedia. This is actually not the best choice. So overall, German and French DBpedia yield slightly better results. So for all of those people out there using the English DBpedia as the default setup, it might not be the best default setting. And what we were more interested in, though, were these categorical differences. So the first thing we looked into was the production country of those movies. So for all of these movies, we annotated them with the production country. And then we looked into how likely is it that a particular recommender recommends movies from that production country. So here we have the top 10 production countries: USA, UK, France, Germany, and so on. And we have these 5 recommenders trained on the German, the French, the Italian, and so on. DBpedia. And we see some interesting differences here. And so the first thing is there is actually a lot of variance. So for example, if you look at this UK production country, the highest fraction comes from the French one, which is 14.3%. The lowest one comes from the Russian one, which is 9%. So there's already some considerable differences on both sides of the expected value. So the expected value is 11%, and there are recommenders which recommend more than that. There are others which recommend less than that. What I marked in blue here is what you would actually expect. So from our initial hypothesis, we said, well, the German, the one trained on the German DBpedia should have a higher tendency of recommending movies from Germany. But this is not the case. Same here. So the highest fraction of French movies is recommended by the one trained on the Russian recommender. The highest fraction of German movies is recommended by the recommender trained on English. The highest fraction of the one trained in Italian is recommended by the German one, and so on. So there is a lot of variance in here, and it actually does not confirm our initial hypothesis, but still we observe this variance. When we looked at the top 10 genres, on the other hand side, we also wanted to see, is there some interesting patterns in there? And actually, we also see some variance. So, so for example, if you look at drama, there is a lot of recommendations coming from Germany compared to fewer from Russia. If you look at, for example, action movies. Action movies are pretty salient on the Russian DBpedia, but are almost never recommended by the one trained on French. If you look at children's movies, on the other hand side, you see a lot of children's movies are recommended by the recommender trained on French DBpedia. A lot less are recommended by the one trained on the Russian DBpedia. So there is a lot of variance in here. We wanted to see, is there any possible explanation? So we took some external data where people looked at the popularity of certain genres across the world. And we see actually from those 5 languages we have here, actually Russia is the country in which action movies are more popular than like in Italy and France and so on. So we see that reflected in our external data. Same for comedy. So Italian, the version trained on the Italian DBpedia has the highest probability of recommending comedy movies. And we also see that comedy movies are particularly popular in Italy. So we see that these cultural differences, they reflect in Wikipedia, they are carried over to DBpedia, and finally, they also show up in the downstream system, like the recommender system in our case. Finally, we also wanted to look at, does the recommender generally behave better with respect to certain genres? And actually, we also see a lot of variance in here. So for example, if you look at the performance solely on the drama genre, then the French recommender is best. If you look at the one on the comedy genre, then the German one is best, and so on. So we also see, if we want to train a recommender, and then we look at how well does it perform for a particular genre, there is a lot of difference in here. And some of these differences are really striking. So for example, here we have for horror movies, the performance of the English one is about twice as high as the Russian one, and for children's it's even more than that. So here we have the best one for the German one, which has a F1 score of nearly 21%, and the worst one, the Russian one, has one of 6.4%. So it's almost a factor of 3 that divides them. So what did we observe in our experiments? We observed that these downstream systems trained on these different knowledge graphs, they have a bias towards different production countries that was significant, but it was not as expected. So it was not as straightforward as saying, well, if you train one on the German DBpedia, it has a higher tendency of recommending German movies. But we have significant differences here. And we have very strong significant differences with genres. And we also looked at external data to validate that. So we see that if a particular genre of movies is popular in a certain country, we also see that reflected in the behavior of the downstream system. So we also want to look at further biases which might be interesting. So we looked at genres so far, we looked at production countries so far, but the method itself we use is pretty universal. So as long as you annotate some categorical features on these items to recommend, you can inspect the behavior with respect to that feature as well. So you could easily, with the same methodology, inspect whether there is a gender bias. So do certain systems trained on a particular DBpedia have a higher tendency to recommend movies by male or female directors? Is there something like a racial bias? So is there a stronger tendency to recommend movies starring people of color if you use one knowledge graph or the other, and so on. And of course, we can also extend this to other knowledge graphs. So far we've looked at language editions of DBpedia. You can also do DBpedia versus Wikidata versus other knowledge graphs. So some take-home message. The first one is the knowledge graph matters, and there is no one-size-fits-all solution. So when we looked at these top performances across the 10 genres, we saw a lot of variance. For 5 genres, the French one was best. For 2 each, German and English was best. And for 1, Russian was best. And we also saw that despite the Russian DBpedia yielding the worst overall recommender, it was still the best one when it came to recommending crime movies. So you should never underestimate the impact that the choice of a particular knowledge graph has on the downstream performance of your system. And as you can see here, most people use English DBpedia by default, but it was only the best in 2 out of 10 genres. So look at what is around as well, apart from English DBpedia. And the second take-home message is I want to make a point here for rethinking what we do when we do parameter tuning and ablation studies. So we see all these ablation studies on different methods, parameters, pre-processing techniques, etc. But we never or very rarely see them for knowledge graphs. And on the other hand side, our experiments show that this can actually yield some considerable differences. So in some cases, there was a difference by a factor of 2 or 3 when we looked at the performance for different genres. So the choice of a knowledge graph could actually change the overall performance of your system by a factor of 2 or 3. So why not consider that when you think parameter tuning, when you think ablation studies? So think of the knowledge graph to be used as yet another parameter to be tuned. So with that, I want to close this talk. I thank you for listening, and I'm online now to answer your questions. Thanks for your attendance.